introduce this idea of how your choice of origin actually changes the nature of the mathematics of the problem, even if it doesn't change the nature of the physics. I want to give an example that you actually thought about a little bit back on Module 2, and that I hope you'll start to think a little bit harder about now. So it's an example of a pencil that's lying on the table, and I'm going to apply a force to it. I'm going to apply a force to it at a point here close to the bottom. And I'd like to know the answer to the question, well, what's the force on that object? What's the torque on that object? Well, the force on the object, I've just told you what the force is, right? So I've got a force, according to me, in this coordinate system. My net force is simply whatever I'm applying in the i-hat direction. Well, what's the torque on that object? Well, the torque is going to depend on what I choose for a coordinate system. So I could, for example, choose this to be my coordinate system. So let's call that coordinate system number 1. Well, the torque in coordinate system number 1 is going to be r cross f. Well, r is going to be in the i-hat direction, f is in the i-hat direction, i-hat cross i-hat is 0, so the torque in coordinate system number 1 is 0. Okay. What if I were to choose my coordinate system instead as being this, right, through the center of mass of the object? What would the torque be in that case? Well, the torque in this case, let's call that coordinate system number 2. I'd have a r that was minus L on 2 in the j-hat direction. So my torque in this case would be minus L on 2 j-hat cross with f I-hat. J-hat cross I-hat is minus k-hat. So I get f times L on 2 in the k-hat direction. Right? Okay, so that seems to give me a torque that says that it would be wanting to rotate counterclockwise, torque coming out of the page. And finally, I could actually choose this as being my origin, right? I could choose this as being origin number 3, and the torque about origin number 3, well, let's see, that would be, let's say this is L over 2 as well, so this position vector would be plus L on 2 j-hat, right, going from the origin to the point where it's applied. So I get plus L on 2 j-hat cross f in the i-hat direction. So I get minus f L on 2 k-hat. So I've chosen 3 different origins, 1, 2, and 3. And for those 3 different origins, I've actually gotten 3 different values of torque. I've got 0, I've got a positive torque, and I've also got a negative torque. This seems really bad, doesn't it? I mean, it seems like you're going to have a lot of trouble getting the same physics out if you actually use different origins and get different torques as a consequence. And it's tempting to think that's the case, but you need to also keep in mind that it's not just torque that depends on your choice of coordinate system. Your angular momentum also depends on your choice of coordinate system. So remember that the angular momentum of this object, right, this pencil, is going to be r cross p plus angular momentum about the center of mass times the angular velocity as measured about the center of mass, right? Because we're going to have an object here which will end up both rotating and translating. And so pretty clearly, if I choose origin 1, I'm going to have a different value for this r cross p for the center of mass, right? This will be what my r is for the center of mass for origin 2, for origin 1. For origin 2, this first term will be 0, right? I don't have anything going on with respect to the center of mass because I'm located at the center of mass. And for origin 3, I'll have yet another r that goes to the center of mass. So even though the torques are different in all 3 cases, the angular momenta are going to be different in all 3 cases as well. And so it will actually turn out that for all 3 cases, it will still work out that the sum of torques is going to be equal to the time rate of change of the total angular momentum of the system. What you calculate for the total angular momentum of the system will be different for all 3 cases, and what you calculate for the torques will be different for all 3 cases, but they will give you consistent behavior for all 3 cases.